Okay, we're back. Hello to everybody. We've got a kind of a big slide here. It's busy. There's a lot of stuff. This is how we're controlling the layers, but we're going to set this all up first. This was the blown up, magnified demonstration of what happens when you get transmitted power, radio frequency transmitted power levels low enough to generate quantum mechanical effects. This again is a cutaway, trimmed down version of the piston. Here's the piston. And the piston moves inside of the cylinder. And here is the cylinder. And we've cut away a lot of the parts in order to let you see what's going on. We're going to be talking about a mathematical discussion of what we can do. And so we have a graph here that lets us do math. And these are data points. So if we wanted to take a data point and put it on the graph, we can put it on the graph. And there it is right there on the graph. And we'll put it back over here. Before we go far into this, we are going to talk about a little bit of what we're doing here. And basically, we are using a measurement of one variable. So we'll take our piston. And you can see if we take our piston, here is piston transceiver 1. And if we want to look at piston transceiver 1, right here, piston transceiver 1 is broadcasting energy through the piston. Then it's going to come here and broadcast energy through the cylinder wall. And we can see that with respect to this E cylinder wall channel, that the opening of the door for transmission of power from piston transceiver 1 into E, that doorway is very small. And so that's why we're showing quantum mechanical power output levels. And so we're looking at a measurement of power being transmitted from this part of the piston, the inside portion of the piston, through the piston and through the cylinder. And we're measuring one variable so that we can make a discussion about another variable. And you might say, well, what is that exactly? And so we'll give some examples. We can talk about the example of, for example, a city that has a stadium. And this city is actually a littler town-type city next to the big city, and the stadium is the stadium for the big events from the big city, and the little city that is the property where that stadium is present, that city needs to make plans depending upon what's going to happen with that stadium. And in essence, if there's nothing going to be happening at the stadium, then the city doesn't have to do anything. But if an event is planned, then the city is going to have to make some plans. And let's say, for example, one of the plans they need to make plans about is sewerage, because when all these people show up at the stadium, they're going to generate a certain amount of sewerage flow that is in excess of what is normally present at the city. And so the city will have to plan to have perhaps extra chemicals on board at the sewage treatment plant, or perhaps extra filtering capacity or extra people. And so the city would want to know how many people are going to show up at the stadium. And there's no way in the future to know when that's going to happen other than to predict the future. And one of the things the city could do if it wanted to, for example, would be to go to the city and say, please tell us what your ticket sales are for the stadium, because the magnitude of the ticket sales can be used to generate an opinion about how much sewerage flow is going to happen when the event happens. And so you're actually measuring one thing, which is ticket sales, and using the measurement of that one thing to generate an opinion about what is the value of some other thing, that is, how many people are there. And in a similar manner, at the end of whatever is going on there, when the stadium empties, the police are going to have to make plans for how many people are there and how many policemen they're going to need to get the traffic flow, et cetera, et cetera. And so another thing that could be done if you wanted to is during the event that's going on, the police department could ask the stadium to give the police department a measurement of the sewage, the total sewage flow output from the stadium. And that output of sewage in real time is related to how many people are in the stadium. And so again, you would have a way that you could measure one variable, which is sewage flow from the stadium, in order to predict an opinion about a different variable. And the final example we'll mention is in the world of aviation. The aviation world needed to know what is the altitude of an airplane. In the old days, that was not simple to do. Currently, it is possible with radar to measure altitude by bouncing radar from the plane down to the ground and back from the ground to the plane. This type of sophisticated radar capability did not used to exist. Instead, they would use a principle of atmospheric pressure, which is that the atmospheric pressure at any particular altitude has a specific value. And the way they would establish the altitude of the plane is that they would measure the air pressure around the plane. Then they could refer to scientific graphs where if this is the air pressure surrounding the plane, then this means that the plane must be at this particular altitude. So they are using a value of air pressure around the plane and using that variable to create an opinion about what is the result or what is the value of a different variable. So the first variable that they measured was the air pressure around the plane, and then they would infer from that what is the altitude of the plane.